In this video, I'll be going over trig identities and how we can simplify them. So the first thing to mention is the definition of what an identity is. And this is an equation that is true no matter what values that the variables are assigned. So some examples of identities that you may have seen before are things like x equals x, y squared is equal to y times y, maybe 1 times a is equal to a. Okay, so in each of these, no matter what value we assign to the variable, so for example, in this one, x is equal to x, if x is equal to, let's say 5 is equal to 5, that is true. We could pick any real number there, and the left side will equal to the right side. So all of these are examples of identities. Now in trig, we have a lot of identities, and they can take sometimes complicated looking forms. And we're going to be manipulating these to simplify different expressions and make equations equal to each other. So with that in mind, let's go through some of the most common identities that we've already seen in this class. So the Pythagorean identities are cosine squared of x plus sine squared of x is equal to 1. That's the most basic of the Pythagorean identities. There's two other versions. Let me see if I can make a copy of this. And then if I paste. Okay, so if I take that identity and I divide each term by cosine squared of x, what we're left with is 1 plus sine squared over cosine squared is tangent squared of x is equal to secant squared of x. So that is a second version of the Pythagorean identity. And then we have a third version. See if I can squeeze it in there. The third version, now let's say I divide each term by sine squared of x. Okay, and what this comes out to, cosine squared over sine squared is cotangent squared of x. Plus 1 is equal to 1 over sine squared is cosecant squared of x. So that is a third version of the Pythagorean identity. So my suggestion would be to memorize the first one, the cosine squared plus sine squared is equal to 1. And then if you can remember how we get to the other two, you don't really need to memorize those. All right, we've also already seen the even and odd identities. The even identities what we should say is the even trig functions are cosine, and that just means cosine of negative. And before I go any further, one thing I want to say is that up above I was using x for all the angles. The variable that we use is arbitrary, so I could use x, I could use y, a or b, or theta. So it doesn't matter as long as I'm consistent where that variable is. So I'm going to use theta for this next one. Cosine is even, which just means cosine of negative theta is equal to cosine of theta. Similarly, secant of negative theta is equal to secant of theta. So cosine and secant are the even functions, and then the other four are the odd functions. And how that works is tangent of negative theta is equal to negative tangent theta. And then cotangent is the same. And then we have sine of negative theta is equal to negative sine of theta. And then cosecant of negative theta is equal to negative cosecant theta. All right, so there are the even and odd functions and just how those operate. We've already seen the reciprocal identities. All of the 6 trig functions we can write as a reciprocal of another function. So sine is the reciprocal of cosecant. Similarly, cosecant is the reciprocal of sine. Okay, and then cosine of theta is the reciprocal of secant, and vice versa. Secant theta is equal to 1 over cosine. And then lastly, tangent and cotangent are reciprocals of each other. Okay. Do a better theta there. And then I think the last ones for this page are the quotient identities. And this just means some of the functions we can write as a quotient of two other functions. So we can write tangent theta as sine of theta divided by cosine of theta. And then similarly, cotangent of theta we can write as the other way, cosine of theta, cosine of theta divided by sine of theta. Okay, so there we go for the quotient identities. So these are the basic identities that we'll be using quite a bit here. Now let's see why, or I should say, let's see how we can use these. So the first way we'll use these is to simplify a trig expression. And when we talk about simplifying a trig expression, what we want to do is we want to see if we can get the expression down to one term, one trig function, and then we don't want to have any fractions. And all of these things are not always possible, but we want to do these. Do these if possible, we'll say. Okay, so for example, we may be able to get the expression down to one term and no fractions, but we might not be able to get one trig function. So it just kind of depends on the situation. All right, so let's look at a few examples of how this works. This first one says, we want to simplify sine of x times cosine of x times cosecant of x. Now, one thing, or I guess one kind of strategy is always to convert everything to sine and cosine. Sine and cosine, they're kind of like the building block functions in that the other four functions can all be written in terms of sine and cosine. So I already have a sine here, I have a cosine, but this cosecant of x I can write as 1 over sine of x. Then I'm just going to rewrite everything else down here. Okay, and what we notice is that I have a sine of x over 1. So this sine of x will cancel with this sine of x. And what I'm left with is just cosine of x. And what we notice, I have one term, one trig function, just cosine, and I don't have any fractions. So that's as far as we can simplify here. Continuing onward, sine of x and cotangent of x, sine of negative x and cotangent of negative x. So these are both odd expressions or odd functions. So sine of negative x is the same as negative sine of x. Cotangent of negative x is the same as negative cotangent of x. I'm multiplying those two together. But again, I'm going to rewrite cotangent of x in terms of sine and cosine. Cotangent of x is cosine over sine. So this will be negative cosine over sine. And then I have negative sine of x over here. And so similar to the previous one, I can cross cancel. If I put this over 1, I can cross cancel this sine with this sine, and then I'm left with negative 1 times negative cosine, which coincidentally is also cosine of x. All right, a couple more examples here. Simplify this expression. Now this looks a lot more complicated, and it is, but we can still tackle this. So again, I'm going to rewrite cosecant of theta in terms of sine, which is 1 over sine. And then I have this cosine of negative theta here. And so I'm going to address those two things first. I have 3 sine cubed of theta. And I want to say something about this here. So sine cubed of theta is the same thing as sine of theta cubed. So we put the exponent between the function and the angle here. So we'll see that repeatedly as we go along, but just know that that's what that means. Cosecant theta, so that's 3 sine cubed theta times cosecant. I'm going to rewrite that as 1 over sine of theta, plus cosine squared theta, can't do anything there. And then I have that negative angle. And since cosine is even, cosine of negative theta is equal to cosine of theta. Okay, I said that backwards, but it's as though I can drop that negative. So this is 2 cosine theta times another cosine theta. So one thing to notice is I have these 2 cosine thetas getting multiplied together. So that's 2 cosine squared theta. I'm going to bring everything else down. One thing in this first term, in this term here, we have cosine cubed divided by, or I'm sorry, sine cubed divided by sine. So what that's going to do is I'm going to cancel that, and then this is now going to become sine squared. So I have 3 sine squared theta plus cosine squared theta plus 2 cosine squared theta. And then cosine squared plus 2 cosine squared. One way to think of that is x squared plus 2x squared. Same thing. All that means is I'm going to have 3x squared. So this is 3 cosine squared theta, 3 sine squared theta, and those are getting added together. So we've gotten a little more simplified. We've gone from 2 terms to 1 term, but I don't have a single term, and I still have 2 trig functions. So one thing you can do is we can factor out a 3 from each term, and what we're left with is sine squared theta plus cosine squared theta, and this is going to appear quite often. This is everybody's favorite trig identity. That's the Pythagorean identity, and that is equal to 1. So when it's all said and done, this is going to be equal to 3. 3 times 1, maybe I'll write it like this. So 3 times 1 is equal to 3. All right. So that one was a little bit longer, but same principles that we've been dealing with. Next, let's simplify this expression. I have 2 fractions. Anytime I'm adding fractions, I want to get a common denominator. The first thing I want to do, though, is I want to address this negative argument. And remember, cosine is an even function. So it's as though that negative goes away. And then I can do 1 minus cosine x here. Okay, so just like when we're adding fractions, we need to get a common denominator. So the common denominator, the first fraction has a denominator of 1 plus x, the second is 1 minus cosine of x. So the common denominator is going to be 1 plus cosine x, 1 minus cosine x. Okay, so this first fraction, I'm going to multiply by 1 minus cosine of x divided by 1 minus cosine of x. And then the second fraction, I'm going to do 1 plus cosine of x over 1 plus cosine of x. Okay, so multiplying those two things, those fractions together in each term. This first fraction, I have 1 times 1 minus cosine x, so that's just 1 minus cosine x divided by, well, I have that common denominator, plus, in the second fraction, I'm going to have 1 times 1 plus cosine of x, so 1 plus cosine of x. And then in the denominator, I have the same thing. So what we notice is that the denominators now are the exact same. When the denominators are the same, that's when we can add fractions. So adding the numerators, I have 1 minus cosine x plus 1 plus cosine x divided by that common denominator. Okay, and one thing to notice is that I have a negative cosine x and positive cosine x, so that's 2 in the numerator. And in the denominator, when I multiply this out, I'm going to get 1 times 1 is 1, plus cosine x minus cosine x squared. So when I simplify that, that's 1 minus cosine squared x. And this thing right here I'm going to write that over to the side. Remember, anytime, well, I shouldn't say remember because I haven't said this yet, but when we see something with a 1 and either sine squared or cosine squared, it's possible that it can be manipulated from the Pythagorean identity. And so what I have in the highlighted portion in the denominator, 1 minus cosine squared x, isn't exactly what I see in this Pythagorean identity, but if I subtract cosine squared from both sides, I'm left with sine squared of x is equal to 1 minus cosine squared of x. And so I can replace in the denominator that 1 minus cosine squared x with sine squared of x. Okay, so we're pretty close. We have one term, we have a single trig function. I still have a fraction though. And remember, 1 over sine squared of x is the same thing as cosecant squared. So this is 2 cosecant squared of x. And that's how we get there. All right. And then the last example here says, simplify the first expression. So this is our first expression. By writing the simplified form in terms of the second expression. So in other words, we want to write that expression cosine of x over 1 plus sine of x plus tangent of x. We want to write it so that we only have cosine in it. So let's see what we have. I have two things that are getting added together. The first is a fraction, the second is not. So what I need is, in that second term, I need to multiply the top and bottom by 1 over sine of x so that I can get a common denominator and then add that to the fraction. Okay, so that is getting multiplied by tangent. I'm just going to bring down the first term. Okay, so I'm going to rewrite this tangent over 1. So when I multiply, I get the same denominator. This will be cosine of x over 1 plus sine of x plus, I'm going to distribute the tangent into the numerator. So that's tangent of x plus tangent of x times sine of x, all divided by 1 plus sine of x. Okay, notice we have common denominators here, so I can write this as a single fraction, 1 plus sine of x. In the numerator, I have a few terms. I have cosine of x plus tangent of x plus, what I'm going to do here, let me write this over to the side, tangent of x times sine of x. Remember, tangent of x is, I think I'm going a long way on this one, but let's see what happens. So tangent of x is sine of x over cosine of x, and that's getting multiplied by sine of x. So that simplifies to sine squared of x over cosine of x. So that's what I could replace this with here. But then I'm going to have a fraction inside of another fraction. I don't think I want to do it that way. So I think I could eventually get there, but let's actually take a little bit of a different approach. So I'm going to start over. So cosine of x over 1 plus sine of x plus, instead of writing tangent of x, I'm going to go right off the bat and write that in terms of sine and cosine. Okay, I think this is going to be a little bit easier for us. So what I need to do is get a common denominator between these two fractions. Let me move this so I have a little more space. Okay, so in the second, the denominator is going to be 1 plus sine of x times cosine of x. So in the fraction over here, I need to multiply the top and bottom by 1 plus sine of x. And then in the left fraction, I'm going to multiply the top and bottom by cosine of x. Okay, so multiplying those together, the left fraction, I'm going to get cosine times cosine is cosine squared of x divided by that common denominator. Plus, on the right-hand side, I'm going to distribute the sine. I get sine of x plus sine squared of x divided by cosine of x, 1 plus sine of x. Now that those denominators are the same, I can go ahead and combine the fractions. Okay, so this is cosine squared of x plus, I'm going to write the sine squared next, just because that is a Pythagorean identity. And then in the denominator, I just need to write that denominator one time, and I'm going to distribute here also. So this is cosine of x plus cosine x times sine of x. All right, so let's do a little bit of combining and simplification. This thing right here is Pythagorean identity. That is equal to 1. So in the numerator, I'm going to have 1 plus sine of x, and I'm actually going to back up here and not multiply this denominator out. Because what we'll see is, in the numerator, I'm going to have that 1 plus sine of x. In the denominator, we had cosine of x times 1 plus sine of x, and those terms are going to cancel. So what we have left is 1 in the numerator divided by cosine of x. Okay? Now, backing up to what the instructions said on this one, it said, write the answer in terms of cosine. So that answer that I wrote is in terms of cosine. It only has cosine in it. If I wanted to fully simplify this, I wouldn't want to have a fraction. And so what I could have also written is secant of x. But again, because this, we want to write this in terms of cosine, 1 over cosine of x is what we want. And then I'm just going to say one last thing about this question. We went down this route over here, and it kind of seemed like it was a dead end. So I, started over and with a different approach by using changing the tangent first. And then I also saw that, well, when I got down to here, I multiplied that out. But then again, I saw that that didn't really get me what I wanted. So let this be an example of what is very common in these examples or these types of problems when we're working with trig identities. It's very common to, go down one route and then realize, maybe this isn't the best way to do it. I'm going to try something else. So that is a habit that, especially if you've never done these types of problems, that's a habit that you want to get into, which is specifically the first approach isn't always the correct approach or the fastest approach. And so you need to be comfortable trying things, and if they don't work, trying something else.